Imagine, if you will, the world ending tomorrow due to an alien invasion. How could that be possible? Now, this might seem like a plot straight out of a science fiction novel, but let's delve a bit deeper. Ponder the vastness of our universe, an expanse so grand that the human mind finds it difficult to comprehend. It's sprinkled with galaxies, stars, and planets beyond count. The concept of extraterrestrial life isn't so far-fetched when we consider this immensity. Could we really be the only sentient beings in this sprawling cosmic arena? This brings us to the Fermi paradox, a puzzling contradiction. It questions why, despite the high probability of extraterrestrial life and the enormity of observable universe, we still haven't found any evidence of their existence, nor have we made any contact. So if the universe teems with life, the question remains, why haven't we met any aliens yet? The universe, with its billions of galaxies, each containing millions of stars, seems like a place where life should be abundant. But where are they? To ponder this conundrum, many turn to the Drake equation, a mathematical formula proposed by Frank Drake in the early 60s. This equation was not designed to provide a definitive answer, but rather to stimulate scientific dialogue about the abundance of extraterrestrial life. The Drake equation considers several variables. These include the rate of star formation, the fraction of these stars with planetary systems, the number of planets that could potentially support life, the fraction of planets where life could evolve, the percentage of life that could develop a civilization capable of interstellar communication, and the length of time such civilizations might be able to communicate. The results from the Drake equation can vary widely, producing a range from a pessimistic few to an optimistic millions of civilizations, all depending on the values you assign to these variables. But even at its most conservative estimate, the equation suggests that we are not alone. However, the Drake equation does not tell us the nature of these potential civilizations, their intentions, or their technological capabilities. It merely suggests their potential existence. The Drake equation, while not definitive, suggests that we are not alone. But if that's the case, what might an encounter with an alien species look like? Let's ponder on this. An alien civilization, advanced enough to reach us, decides to invade. What could be the possible outcomes? Imagine, if you will, a spectrum of scenarios. On one end, we have peaceful contact. Perhaps these extraterrestrials are benevolent, enlightened beings. They might want to share their knowledge, ushering us into an age of unprecedented prosperity. Or they may simply be curious, fascinated by human life in the same way we're intrigued by alien existence. But let's venture towards the darker end of the spectrum. A hostile takeover, a concept all too familiar in human history, could be a grim reality. Whether for resources, which might be scarce in their home planet, or a desire for colonization, we could find ourselves outmatched and overwhelmed. These advanced beings might possess technology that we can't even begin to comprehend, making resistance futile. And of course, there's the middle ground, a scenario of mutual destruction. Perhaps the aliens underestimate us, or we overestimate them. Regardless, the result could be a devastating war, leaving both civilizations in ruins. Then there's the question of why. Why would they invade? For resources, as mentioned earlier, or maybe it's a matter of necessity, a desperate bid for survival. Or it could be for scientific curiosity, a desire to understand the universe and its myriad of life forms. So the end of the world might not be as far-fetched as it initially sounds. If an advanced alien civilization does exist and decides to invade, the consequences could be catastrophic. So, we've explored the concept of alien life, the probability of their existence, and the potential scenarios of an alien invasion. But what does all this mean for us? To wrap it all up, we've taken a journey through the vast cosmos, pondering the existence of life beyond our little blue planet. We've considered the mathematical probability of such life, finding that it's more likely than not, given the sheer number of planets in the universe. We've also dared to imagine the unimaginable, a world faced with an alien invasion. We've explored a variety of scenarios from peaceful first contact to cataclysmic conflict, each one fascinating and terrifying in its own right. Yet, with all this speculation, the truth remains shrouded in mystery. Are we alone? Or is there someone else out there looking up at their night sky wondering the same about us? It's a question that may never be answered, but one that's worth asking. In the end, Whether we're alone in the universe or not, the exploration of these questions helps us to understand our place in this vast cosmic arena. Until next time, keep looking up.